Okay, problem 7.31. Consider we have two continuous random variables x and y. They have a joint PDF given in this way. So when x and y are both between 0 and 1, the density function is 12xy times 1 minus y. Otherwise, it will be just 0. Okay, otherwise it will be 0. Now, let's say the question is to determine the joint PDF of these two new random variables, z, which is equal to x and y squared, and the u, which is just identical to y, and also find the marginal PDF of z. Okay, so recall that first, the x is between 0 and 1. So as you can see, if x and y are both between 0 and 1, the z has to be between 0 and 1 as well. Right? And also u just equal to y, so that's why u has to be between 0 and 1. So remember, this is the where the joint PDF of z and u can be positive. Okay, outside of this domain, the joint PDF must be equal to 0. Okay, now we define a function v of x and y. That is just simply recalling what we have here. This is x and y squared, we just copy it here, and this is y, just copy it here. So that means the zu is equal to v of x and y. Z equals to x y squared, and the u equals to y. So now we try to solve for x and y, and we'll get the inverse of this function. So by solving x and y, we can see that the y is simply just equal to u, and x is equal to z over y squared, and that's then just equal to z over u squared, because z equals to, u equals to y. Okay, so that is actually the inverse of the v. So the inverse of v is just this w, denoted by w. That is just z over u squared and u. Okay, now compute the Jacobian. Jacobian is just taking the derivative of this guy with respect to z, which is what I got here, and then take the derivative with respect to u, and that's how I got this guy here. Similarly, we're going to take the partial derivative of this with respect to z, that's 0, and then derivative with respect to u, that's 1. So that's the Jacobian matrix, and taking the determinant of this Jacobian, I'll get just 1 over u squared. Okay, so now we're ready to figure out the PDF. So the PDF of z and u is just z, g, we denoted by gzu. So according to the theorem we had in class, so that's just the PDF at w of zu times the absolute value of the determinant of the Jacobian matrix. So the f is, remember that is 12xy, 1 minus y. So 12, this is the x, this is the y, this is the 1 minus y. Okay, and then the determinant here, we know that's just the 1 over u squared, that's why just get a 1 over u squared, it has to be non-negative, it has to be positive actually. So that is combining all of them together, that's how we got the PDF, joint PDF of z and u, and that is the z and u has to be between 0 and 1, right here. Okay, didn't do the marginal one here, so the marginal distribution of z, we should do the marginal of z, right? The marginal distribution of z is just taking the integral of the joint density with respect to the variable that you are not interested in. So here is the u, so that's just between, u is between 0 and 1, so I can do that. And this guy here is just 0, 1, 12z 1 minus u, u cubed du. Okay, so now z is treated as a constant. You can pull it out and just integrate the others. Okay, so I didn't do that computation here. You can see that's just a simple integration, and you get the answer. Okay, so that is the marginal PDF of z. And the z is between, so the z has to be between 0 and 1. Right? Outside of this interval, the g sub z is just equal to 0.